Okay, so today we're going to go over the sandwich theorem. And what the sandwich theorem says, if we cannot find a limit directly, we may be able to find it indirectly with the sandwich theorem. It refers to a function f, which I'm trying to draw right now. Okay, so let's call this f, whose values are sandwiched between the values of two other functions. Let's call it g. And h. Okay. When I was drawing f, I was trying to create something that was oscillating over here. Usually that's the case when we're not able to find its limit. So we can look between the two functions g and h, and they have the same limit as x approaches c. Let me put c down here, and that is L. Okay, then f would have that limit too. Okay, so please write this out. If g of x is less than or equal to f of x, which is less than or equal to h of x, we have this compound inequality for all x that is not c, okay, in some interval about c. And the limit of g of x is the same as the limit of h of x, and that equals L for when x approaches c. Then the limit of f of x will also equal L. Okay, that is the sandwich theorem, and it's true because of this inequality. Now, this is our example of f is oscillating. You may still find the limit, but note that this does not mean that it is now continuous. Okay, somewhere where it oscillates, there is some hole in the graph, so it's still not continuous. We're just able to somehow find the limit. Okay, so we have 3 steps to do that. And so we're going to do an example together to show those 3 steps. Okay, so in this example, it says the limit of the function x squared times sine of 1 over x, okay, it equals 0. So we actually know the answer, okay, but it's saying to show that this is true. This is as x approaches 0. I'm sorry for excluding that in my reading. I got a little jumpy and excited. I knew the answer was 0. Who can blame me? All right, first step is to understand that this is involving the sine function. Okay, and the sine function, we know, has a value of 1 as its maximum y and a minimum value of -1. Okay? So that means that for the values of sine, they lie between -1 and 1. For this, it's a sine of 1 over x. So we know that its values are between -1 and 1. So we could write it this way, or we could write it this way. Okay, with the absolute value. Okay, either way, it's the same expression, and that's our first step, is to understand what we're working with here. Our second step, where is this? Number 2, is to take this expression and break it up, okay, the whole thing now. So this we could say is the absolute value of x squared sine of 1 over x, okay? That would break it to absolute value of x squared times the absolute value of sine of 1 over x, okay? And we know that this is greater than or equal to 1, so that means if we had multiplied by the absolute value of x squared on one side of our inequality, we must do it to the other side. Okay, so this is balancing an equation, just like we have been doing in years and years past. So here we get our expression x squared sine of 1 over x, and over here we have our absolute value of x squared. Okay, and so what that gives us is that our x squared is very similar to what we're working with before, saying it could be a compound inequality. All right, so we're going to take that understanding and say that it's negative x squared that's less than or equal to this expression. And the positive x squared, okay? This is saying basically you have g is less than or equal to f, which is less than or equal to h. We're now using the sandwich theorem. Okay, and if you're wondering why we have the minus and plus, this is how we solve all absolute value problems. Okay, you have case 1 where it's a negative answer, and case 2 where there's a positive answer, or case 1 where inside the absolute value is positive, or case 2 where it's negative. However you're used to solving it, you still have the negative and positive. So that's how we're setting it up, how we solve absolute value problems. So you got to know that to understand why I did this. Okay? All right, so with that being said, we can now continue to step 3. So I'm going to raise a little bit here. Okay, so we took our expression, our understanding of sine, created an inequality with absolute values. We solved the absolute value inequality. So now we're up to understanding what to do from here. Okay, and once you saw the inequality, it resembles or represents the sandwich theorem, then we can talk about its limit, like the limit of g and a limit of h. It should equal one value, and a limit of f would equal that same value. So the limit of g, the g in this case being negative x squared, and a limit of h, in this case just positive x squared, okay, what they equal. And in this case, it's as x approaches 0, and they do equal the same answer. Da, 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 da. It is 0. Okay, so that means that the limit of our function, x squared sine of 1 over x, as x approaches 0, does equal 0. Okay, and you can also check this graphically. It should be able to show you how f is between g and h, and the limit is 0. So that's not what they're asking here. If it says show, check, prove, determine, verify, we want some sort of algebraic way, and that's where the sandwich theorem comes in. So I want you to practice using the sandwich theorem with some of the problems, and we're done.